No, we'll just keep going and welcome to this second video. So I have already opened model and now in the first tab on geometry, you have like output. Output is the first layer is, and then we can see like assignment gold. That means like the material. And then PMMA is still gold. So we have to change that to PMMA. And chords, so that is why you want to like change the name. Now you don't have to really look at the right hand side. You can just like read a name and know what's the material. Now we have successfully assigned all the materials and we go to the, what is this material? I don't know. Just means we have 3 materials. Now we go to the connections, contacts. And here what we want to do is that we want to like identify or give like the interfacial conductors. And one good way to do this is by like right click this connection and click rename based on definition. Now you can see we have all the names over here. And now you are able to just like directly, just without looking at the other side, just directly give the values. Output to PMMA, that means between gold and PMMA. And now on the bottom here, there's like thermal conductance, you click menu and you give the value here. We have like 59 E6. And the go to, this is just between these two. And we actually separate these several just for the purpose of meshing, and they should not have any interfacial thermal conductances between them, or if they have, it's just like infinitely large interfacial thermal conductance. And that is what this program control is doing, so you don't have to change that. And then for PMMA and chords, we menu and put 300 E6. And PMMA and gold, then it's another 59 E6. PMMA and the heat spot, 59 E6. Gold and the heat spot. No, there's no. Now we finish this part. Then it's the mesh. For this meshing, I'm just using whatever I'm using in my setup. So you have to play around with it. And we also separated the gold layers to several regions just for the purpose of the meshing, because if we mesh all the gold layer to be a really like refined mesh, a small mesh size, then it's gonna take us forever to run the simulation. So we separated into 3 regions, and only the gray region and the green region will have a refined, or will have a small mesh size, and the orange region over here will just have a coarse mesh. And here I also separate like the big this refined mesh region with another like gray region in the center. This is because when we really want to analyze the like ANSYS result to simulate the FDTR, we have to manually output the temperature data, and this part is where we need to just like output, because we don't want to output tons of data that's gonna take forever just to output. So we just want to output even small number of like nodes data. And here I'm using mesh, and you can click, well, this is different from what I have, but I think face mesh and sizing. Let's just insert sizing. And I want the element size to be 1E-7. Oh, sorry, here, 1E-7. Oh, I don't want it to be body sizing. Okay, here, sorry. Here, and you can, let's just delete this one. I'm using a different version on my computer. You change that to solid. That means you're like selecting the body, and you click this one and press Control, click another one and insert sizing. And now you can click type here 1E -7, that is our sizing. And we have another sizing that we want to do because the PMMA is pretty thin and the heat is going down from the gold to the quartz. And we want to have a pretty or relatively good sizing on the PMMA. So we click insert method and sweep. Sweep number, we have like 3. And yeah, let's just use this. Now we generate mesh. You can see this fine mesh over here. And now we start to give the values for the initial temperature. Yeah, it's uniform temperature. ANSYS settings, because we have like a controlled, we have the frequency dependence, so we have to manually set this auto time stepping off. And for this time step, the way that I calculate it is because we have 1E5, so it's like 1 minus 1 divided by 1E5, that is the time for each period. And we want to like separate it into 800 version. So the time we have is 1.25 E -8. 1.25 E -8. And here for the stop, I want to run it for 2000 time steps. So it's 2.5 E -5. And then we insert, okay, this is something that I really want to talk about now, because we have like a FDTR and it's frequency dependent. So this is the part that we need to be most like careful about, because we have to give a Gaussianly decay periodic heating on the bottom of the gold surface. But before that, I remember there is something that we forgot to do. That is, we have to define the bottom surface. So click this and click this, hide body, and click surface. Click this, click this, click this. Insert. Click this, click this, click this. Insert named selection and name it. Rename bottom surface. Okay, now, so this is the name of where we impose our heat flux. And in my next video, I'll talk about how to generate that heat flux. See you in the next video.